The Internet History Podcast is brought to you by MetaLab. Their slogan is MetaLab, we make interfaces. For a decade, MetaLab has helped some of the world's top companies and entrepreneurs build products that millions of people use every day. You probably didn't realize it at the time, but the odds are you've used an app that they've helped design or build. Apps like Slack, Coinbase, Facebook Messenger, Oculus, Lonely Planet, and many more. MetaLab wants to bring their unique design philosophy to your project. Let them take your brainstorm and turn it into the next billion-dollar app, from idea sketched on the back of a napkin to a final shipped product. Check them out at metalab.co. That's metalab.co. Welcome to the Internet History Podcast. I'm your host, as always, Brian McCullough. Kevin Scott is the Chief Technology Officer at Microsoft. Before that, he was at Google, where his work there was influential enough to earn him a Google Founders Award. And he was at AdMob, and he was at LinkedIn. And I believe, actually, he's the first person from LinkedIn that we've ever spoken to on the show. Today, we're going to talk about all of that, but of course, CTO of Microsoft. We're going to get into AI and future tech and all that good stuff that Microsoft is at the forefront of these days as well. CTO of Microsoft currently. I'm pretty sure that's officially the highest ranking current executive at any tech company we've ever spoken to on this show. My thanks to all of the comms people at Microsoft who worked for many months to make this great episode happen. Please enjoy this conversation with Microsoft's CTO, Kevin Scott. Kevin Scott, thanks for coming on the Internet History Podcast.
Thank you so much for inviting me.
You grew up in rural Virginia, I believe, tobacco country?
I did.
What was the name of the town? I was just reading this right before we got on the air.
Yeah, it's this little town called Gladys, Virginia. It's in Campbell County, and I think Gladys in 1972, when I was born, was population 250, and it's still about the same size in 2019. My family still lives there.
Yeah, I was going to write down the name because that's such a pretty name for a town. I was like, wow, that sounds awesome. But all right, so normally the way I start out with people is, their first computer or their first experience with computing, and then depending on the generation, that can range from, Commodore 64 to, yes, the first time I submitted punch cards. So how about you? How did you, literally first experience with a computer that you can remember?
Yeah, I think I'm in the generation of folks where probably my first program that I ever wrote was the 10 print Kevin is awesome, 20 go to 10 on, it was probably like a Commodore VIC-20 or something like that was in a department store attached to a little cathode ray, 13-inch TV. So this was in the early 80s when sort of before the IBM Microsoft flavor of personal computing, but sort of the wave of innovation that happened after Apple had invented the Apple, and so I was immediately captivated because it was the other thing that was happening at the time is console arcade games had started to show up everywhere. Like they were in the lobbies of department stores and in convenience stores, and you had video arcades, and I just loved these games, and I loved these little consumer grade personal computers, mostly because you could play video games on them, and my interest in programming was man, I really want to be able to figure out how to make my own games. And I'd been a tinkerer ever since I was a tiny, tiny little child. Like my mother struggled with me because I would take everything in the house apart to try to figure out how it worked. And when I saw a computer for the first time, I was like, this is the greatest thing that I've ever seen, worthy of being taken apart and understood.
So, do you become a programmer as a child?
Yeah, I did. I around yeah, I think it was probably 12 or 13 years old when I wrote my first real programs, and it wasn't like they were works of art. So I wrote little video games. I wrote at one point when I was a teenager, I was really into Dungeons and Dragons, and I was always a dungeon master. So I like encoded all of the rules of the Dungeon Master's Guide into this little basic. Actually, one it was sort of a big for me basic program, so that I could sit there, very awkward by today's standards, with my Radio Shack color computer 2 tethered to a bulky 13-inch TV, sitting on a coffee table, totally disrupting the ambiance of the Dungeons and Dragons game with
Well, so
everybody around the table.
you ran your games using the computer.
I did.
Wow, that's cool.
Yeah.
Um,
Uh,
yeah, go
yeah.
ahead.
No, and I think like the first commercially useful piece of code that I wrote is my dad. Was a small scale entrepreneur. He owned like a few small construction companies in Central Virginia when I was little, and I wrote all the payroll software for him. So like the thing that kept track of people's time and printed their checks out every week.
It's surprising to me how common that story is for people of our generation, where you get your start by like helping your mom. She's a teacher, so help her do her grades, or
Yep.
your dad. Yeah, it's surprising how common that story is. So because we're roughly of like I'm saying of about the same age, so I would imagine that your first online experiences might have been BBSs or maybe the early online services like Prodigy or CompuServe. Tell me about your first online stuff.
Yeah, I played around a little bit with BBSs. It was interesting for us because Gladys is very, very rural, and so almost everywhere interesting was a long distance telephone call, and like we were fairly, on the poor end of the spectrum most of my childhood. So I didn't have a lot of money to spend on telephone bills, and like I wasn't into the phone freaking stuff, like trying to illegally get yourself access to long distance circuits so you could call into BBSs that were too expensive to get at otherwise. So there were some stuff that I did locally, but I think the first time that I had like real connectivity to the broader world of people messing around with computers was with CompuServe.
CompuServe, of course, being it was known as almost the more nerdy of the services. Like Prodigy was sort of trying to be general consumer, but CompuServe was where you were if you were into computing and nerdy stuff.
Yeah. I mean, it had the stuff that was on CompuServe were the set of things that interested me. Like, by the time I was a teenager, like the magazines that I would buy at the bookstore were Dr. Dobbs Journal, and like I buy the nerdier of the computing magazines. Like I loved Byte magazine. It was absolutely great
Mm-hmm.
because it was, in my mind, like the more technical of all of the many computing magazines that were being published at the time. But like Dr. Dobbs Journal was like my favorite thing in the world. Like anything that could teach me new programming tricks, I was all about. And so that was most of my motivation or interest in being online at all, is to connect with other people who were programmers and to sort of learn new tricks, because I was always trying to figure out, like, you'd sort of see something in a game or an application that was sort of cool, and like I just immediately wanted to figure out how it was done.
So was there never any question you were going to go to school for computer science?
Oh, there were tons of questions. So neither of my parents went to college, and most of my high school experience, or like middle school and grade school, like I just sort of hated it all. It was I used to tell people if like hell is an actual thing for me, it would be, sort of sitting in a seventh grade classroom for eternity. It was just so boring. And I got lucky on a couple of dimensions. My dad, neither my mom nor my dad went to college. My mom, after she graduated high school, moved from uh, this little place in Campbell County, Virginia, to live with my aunt in Richmond, which is the capital of Virginia, for a little while. And she went to what at the time they called a secretarial school, which is sort of like a community college. And she, I think went there for a year or two and then became a bank teller. And my dad had been accepted to go to college, actually the same college I wound up going to, Lynchburg College, which renamed itself to Lynchburg University. But he decided not to go because he hadn't enjoyed school very much either. And like immediately after he declined enrollment, he got drafted and went to Vietnam. And I think he regretted most of his life not going to school, and he just sort of walked around with a lot of expressed regret about the set of turns his life had made. And he put an enormous amount of pressure on me to go to college, and he didn't care for what, but like he just sort of knew that like I was going to go to college and not make the same last minute mistake that he did. And so I would work for him at his construction companies when I was a teenager, just to have gas money. And he would give me the crappiest jobs, and he would tell me he was giving me the crappiest jobs. It's like, okay, like you go run the jackhammer to break up this concrete floor in this dank hot basement of this construction project we're running, or like you get to carry the shingles up the ladder onto a hot roof in the middle of August, or you get to go push the wheelbarrows full of mixed mortar up the hill to the bricklayers. And he was like, I'm going to teach you how miserable this can be. And like I actually don't think that it's miserable work. Like I do a lot of stuff with my hands right now, and like I think there's an incredible amount of satisfaction and dignity and all that stuff. But like this was my dad sort of projecting onto me. And so like I just knew that I was going to college, and that I had a lot of interests, and I still do. Like anybody who knows me, like this sort of looks at my bucket of interest, and they're like, oh, this is sort of crazy, like you're all over the place. And so for me, like I had been really interested in illustration and design when I was a teenager. And so I thought for a while, like maybe I'm going to go to school to become a graphic designer. And when I actually got to college, like I had this tug of war the whole time that I was there between English literature and computer science. Like I was equally interested in both. So it turns out I was better at one than the other. But like I remember getting to um, the end of my bachelor's degree, and the discussion I was having with everyone is like, oh, you should go get a PhD in English literature, and like this other camp of folks like, oh, you should go get a PhD in computer science. And I wound up actually not going immediately to graduate school because I was basically tired of being as poor as I was, and I went out and got a job and tried to save a little bit of money before I went to grad school.
What was that job?
So this was, one of a great many happy accidents in my life. So a couple of pivotal things happened to me in my last year of high school. So I got chosen to go to the Central Virginia Governor's School for Science and Technology, which was this magnet school that the state ran in Central Virginia, and they would take two students from each high school in uh, in basically this multi-county area. Campbell County was part of it, and so there were, I can't remember exactly what the number was, but it seemed to be like there were sort of 40 kids or so in each of 11th and 12th grade, from made up from the top two science and tech students from all of these high schools. And so um, my friend and I got nominated to go when we were both in 11th grade, and they said they would only take one of us. And my friend wound up going that first year, and then the second year they decided that they would take two of us. And so like I got to go to this science and technology high school, and it was like this really amazing experience. And the guy who taught me computer science there went to church with this guy who starting in the summer that I graduated high school was starting his first company. Like he was an electrical engineer, and like had designed power systems and like electronic control systems forever. And like he was starting his company to do some consulting on that sort of work, but to be a contract manufacturer to make printed circuit board assemblies um, for folks who needed small runs of things. Like imagine a Hamilton Beach who needs 10,000 circuit boards for blenders, or like the company that needs like 1,000 circuit boards for a batch of laundromat commercial dryers that they make. And so because my computer science teacher at this high school had known this budding entrepreneur, a man named Robert Roberts, Robert was looking for some summer help. So it was him and two people that he had worked with who were sort of the starting founding team at this company. And like I was flunky number one, and so I went in there and like I just did everything. And it was the thing, like I worked that summer, and then they were like, oh yeah, like you can continue working part-time while you're in school. And so I worked part-time there, probably 20 hours a week the entire time I was in college. And I worked full-time in the summers just to try to make enough money to help pay for school, because my family didn't have enough money to to pay for my college. And then when I graduated, like I just sort of decided to work there full time for a couple of years. And it was like just this brilliant thing. Like I learned so much about entrepreneurship and running a business and flexibility and grit. And then like the really great thing is like Robert was, is one of the best engineers that I have ever met. Like wickedly smart, and like a really great teacher, which is like this fantastic gift to have in your career. Like just sort of being able to convey very complicated concepts to other folks. And so I effectively, even though it was like getting a degree in computer science, I learned to be an electronics engineer at the same time working for this company called Electronic Design and Manufacturing.
Well, and then for many years, like you mentioned, you go on to get your MS at Wake Forest, and but for many years also, unless I'm wrong, you're also in essentially academic computer science, like you're a research assistant and things like that. Like, what are you working on the academic side?
Yeah, so I wanted my goal, like coming out of like that high school experience I had at the Central Virginia Governor's School. Like I had decided I wanted to be a computer scientist, and like not only had I decided to be a computer scientist, like I was really captivated with compilers and programming languages. So like I decided I wanted to be like a compiler programming language specialist. And I don't know like how on God's earth like an 18-year-old figures that out, but that was sort of the way my brain worked. And I took a couple of years off between bachelor's, like get my bachelor's degree and then going to grad school. But yeah, after Wake Forest, I started the PhD program at University of Virginia. Passed my qualifying exams and started working on a dissertation. And most of the work that I was doing there was on something that's sounds fairly arcane. It's this stuff that we we and a bunch of other people, had a lot of enthusiasm and energy around in the late '90s and early 2000s, called dynamic translation. And so the basic idea is if you take a binary program that's running on a microprocessor, what the microprocessor is doing is it sort of like takes the binary program instruction by instruction and sort of runs it, through the silicon on the microprocessor to execute your program. And the idea with dynamic translation is you can insert another piece of software between the program and the microprocessor to translate those instructions on the fly to something else to accomplish some other purpose. So like you're basically rewriting a binary program on the fly. And my work was on how you can very efficiently write a framework that would let you build dynamic translation applications. So like you can use it for a bunch of stuff like security. You can use it to try to do dynamic optimization to sort of like examine a program's behavior as it's running and to sort of optimize it to perform better based on those observations. And so like there's just this wide range of applications that you could potentially write, but like they're very hard programs to write in general, just because you're sort of mucking around in the deepest bowels of the machine, like at the intersection of the operating system and the very back end's output of compilers, and like the raw instruction set architecture and like the computer architecture of these microprocessors. So the framework that I wrote was turned out to actually be somewhat useful. Like there are a bunch of folks who ultimately went on to use the tools that I and a handful of other folks built, to like actually do research and some practical things using this approach to software.
Um, Correct me if I'm wrong, but somewhere in there, weren't you also briefly a research intern at Microsoft?
I was, yeah, my PhD advisor, awesome guy named Jack Davidson, who is like one of the real titans of compilers and programming languages and sort of low level system software. So he's fellow of the ACM. He's yeah, like a whole bunch of the code that he wrote when he was a PhD student influenced the original design of the GNU C compiler GCC. And yeah, Jack went on sabbatical to Microsoft Research, and he took me with him. And like that was a super fun experience. That was 2001, I think.
And by take you with him, like to Seattle?
Yeah, so I went. He was at Microsoft Research in Redmond, and yeah, like the way academia works is like every 7 years or so, you get to take time off to go do something, different. Like you might teach at another school, you might go to a corporate research lab, you might do something else entirely, with the purpose of getting yourself reinvigorated and exposed to new and interesting things. So he moved his whole family to Redmond to be an MSR, to work in this little group at MSR at the time called the Programming Language Systems Group. And he got me a summer internship there at MSR, for which I am eternally grateful. And I packed all of my crap into the back of my Volkswagen GTI, and I drove from Charlottesville, Virginia to Redmond, Washington, and spent several months there working in that research group.
Well, uh, how do you get to Google then? Why abandon this academic research track?
Well, I at some point in all of this, I met my wife. So she she was a PhD student in the history department at the University of Virginia when we met. Um, and we met right after she took her qualifying exams. And she's an early modern European historian, like her specialty is 16th and 17th century German history. And as soon as she passed her qualifying exams, like you start working on your dissertation. And for a historian, working on your dissertation means going to find your documents that are going to be the foundation of the dissertation that you write. And all of her documents were in Germany and sort of the German speaking places in Europe. And so we met. She just passed her qualifying exam. She already had a date by which she was going to pack all of her stuff up and move to Germany. And like we fell in love and like had this quandary of like what on God's earth are we going to do now? And so I through what still is like seemed like another one of these extraordinary pieces of luck that I've benefited from. um, I reached out so she was going to this town in Germany called Göttingen, and I reached out to the computer science department at the University of Göttingen and said like, hey, I'm coming to Germany with my girlfriend. I don't really have anything to do when I'm here, other than sort of spend a bunch of time sending emails back home to my advisor about my dissertation research. Like, is there anything to do in your department? And he was like, oh, this is great. Like, we actually just started this department, and like we're looking for lecturers. You're hired, which evidently never happens in German academia. And so like I had this job lecturing computer science at this new CS department at the University of Göttingen. And like it was sort of like I didn't even like fully appreciate. It was sort of strange that this is 2002, I guess. So it's sort of odd to me that like the University of Göttingen didn't have a computer science department at this point, because University of Göttingen is like one of the best, most storied academic institutions in the entire world. Like Gauss was an astronomy professor there. Like Heisenberg was there. It was this like incredible institution. I was lecturing computer science at the University of Göttingen, and my wife and I wound up staying in Germany for about a year and a half. And we had, before I even went with my wife to or my girlfriend at the time, to Germany, like I had started to get a little bit skeptical about the impact that I could have in academia as a computer scientist. And I wasn't really happy with the way the incentive structures were working there. I was, you spend a lot of time writing a lot of research papers. Like there's this definite incentive to be a little bit incremental. Like the safest thing to do is to like try to push something by 5%. It's like, very dangerous if you're a PhD student trying to get a tenure track job, or you're you are in a tenure track job actually trying to get tenure. There's a formula you can follow where like you go get really good at writing grant applications and pulling in money, and getting a research program where you're sort of going to understand whether or not you will be able to get a reasonable set of outcomes. And like, that's not to say that there aren't people in academia that take enormous risks, but like the risk feels sort of enormous because, if you spend, as an assistant professor, your first 5 years as an assistant professor, like trying to do something incredibly bold that takes all of your resources and all of your attention, and it doesn't work, like you're in real trouble in terms of getting tenure. And so I was looking at this, and like I published a bunch of research papers, and um, the interesting part of my research even seemed like the platform pieces, like the fact that I built something that made it easier for like a bunch of other people to build interesting things, and like that was a harder paper to get published than like writing about like, okay, well, like I use these tools to like make this set of synthetic benchmarks like some number of basis point better than the previous optimization tools, and so there's all of that, and I really loved teaching. Like that was the thing that sort of invigorated me. I got a Intel PhD fellowship at one point that basically gave me the like the funding where I didn't need to teach, and instead, like I got my PhD advisor to let me like run a graduate seminar for the other grad students, and like everybody thought I was a nut. They're like, you shouldn't. You just got this amazing gift where you don't have to do this annoying teaching business. You should be like writing those last few chapters of your dissertation, and like that, just it was like a bag of stuff that was getting less and less interesting to me over time. And then I was in Germany with my wife, and like she went through a real similar transformation. Though the funny thing with her is I'm a super super introvert. Like it's and I still am. It's really draining for me to like be in crowds of people and to chit chat, and like I will like get to some point with these sort of brownie emotions, social interactions, and then like I'll just have to go be by myself somewhere to recharge. My wife is exactly opposite. She's like a mega extrovert, so like she has to be around lots of people and having lots of these interactions in order for her to like have energy. And like the longer she's alone and by herself, like the like the less well she is. And so it was like really odd, like ironically, like you sort of look outside versus in, you say, oh, like historians, like humanities, like these people are like all extroverts, and like that's an extroverted thing to do. And like computer science and software engineering, oh, that's just sitting behind a screen. And like turned out that like computer science is, at least in our narrow experience, my flavor of computer science was way more collaborative than her flavor of history. So she got to Germany, and she was like sitting all day long in these archives in complete silence, surrounded by these, musty documents with no human interaction. And she'd come home at the end of the day from this and just be like, ugh, like miserable. And so and she also really enjoyed teaching, and like we both knew that like if we stayed in academia and like the goal was the tenure track job at the like big important research university, that like we were going to be pushing ourselves in directions that we didn't enjoy. And so we got to the end of our funding, the grants that were supporting us being in Germany, and like we had this decision to make. Okay, we can go apply for more stuff and like double down, and she still needed to be in Germany to finish her research so she could write her dissertation. And she went and applied for a bunch of these things, and I went and looked for jobs in Germany that you could sort of get without having completed your PhD, and being an expat, and like we weren't in a big place like Berlin or Munich or Hamburg, we were, like she was thinking about, going to a place, and like, I was looking at the like Fraunhofer Institute and Fraunhofer Institute in Kaiserslautern. And like we did a bunch of that stuff, and then I was like, okay, well, like we should also like look at some alternatives. And I sent my resume, I kid you not, to Google, and I didn't even know why I was sending my resume there. I knew that a bunch of the compiler people that I really respected, like Urs Hutzler and who had been a PhD student of one of my PhD advisor's colleagues, and there were folks like Jeff Dean whose PhD work was in compiler optimization, like Alan Eustace, who eventually was the head of engineering at Google, was there, and like I'd actually cited his work in my incomplete dissertation and in like a bunch of the papers that I wrote. And I just sent my resume, and I was like, all right, well, if these interesting people are working there, like maybe there's something interesting for someone like me to do. And I got a call back from them, and they wanted to interview me, and I flew out for the interviews, and they were great. They very thoughtfully, this is in 2003, so like year before the IPO, and they had very thoughtfully like looked at my background, and they stacked the entire interview slate with compiler and programming language people. And I was like having these great conversations. I mean, they were interviewing me and like asking me all this tough stuff, but like all of it seemed super fun. And I like walked away from that, and I was like, yeah, this is the thing I ought to go do. Like I still didn't understand like how Google was gonna make any money, or like whether this was a good decision, or like what big contribution I was going to be able to make to either search or advertising. But I knew that it was just a bunch of really wickedly smart people there, and I knew that I enjoyed interacting with them, and I was like, all right, like I'll give this a go. And then on top of that, I got the chance to be one of the first engineers. Like I think I was like number 10 or number 11 in the New York City office, and so like that really sealed the deal. It's like, okay, like my wife and I like really like at the time enjoyed these urban settings. It's like we lived in Germany, like we didn't have a car, like we could walk or bike everywhere. So like being in Manhattan like sounded just great, and so that's what we did.
This special episode of the Internet History Podcast is brought to you by Sonic. We're excited to work with Sonic, the largest independent ISP in California, fighting for customers for 25 years and counting. Sonic is also giving away a first month free to listeners if you visit sonic.com/history. I actually can't get service from Sonic yet here in New York, so I called one of our listeners out in California, a Twitter employee who is a Sonic customer in Berkeley, California, who also has, it so happens, a pretty great name. Brian, you recently got Sonic fiber internet. I think you switched from a previous provider. Why did you switch?
I certainly did. I love Sonic so far. I switched because a few things. I wanted faster internet. I wanted to work with a local company. And I also really wanted a company that really cares about my data, my privacy, net neutrality. And those were all things that really aligned well with what Sonic has to offer.
What's your life like now that you are using Sonic?
It was a game changer in many ways. Being able to stream everything I have. I do a bunch of smart home stuff too, so knowing that everything is accessible. My upload speed is phenomenal, as well as my download speed. And so much so that I come into work and I find that the connection at work is slower than what I have at home. So
right, and
so my home life's better. Yeah.
Even though you're like you said, you're doing like a ton of like Internet of Things stuff in your home, and your wife is using devices, and your kids are using devices, but it's all working out great.
Exactly. No buffering, no one's complaining. It just all works super seamlessly. Uptime is phenomenal too. So
Again, if you want to get the great internet experience that Brian is getting, go to sonic.com/history. That's sonic.com/history. Well, and then you do. It's not the search side; it's the ad side that you work on, right? And the you're saying this is a year before the IPO, but also this is maybe a year or two into Google even having an advertising platform.
Yeah, no, it had had an advertising platform for a while. That
Well,
was
right,
very
but beyond the Tim Armstrong stuff, I'm saying like this is early on in the AdWords AdSense rolling out period.
this is before AdSense had rolled out, and like when AdWords was like in its early days of taking off. Like I was part of a whole bunch of people that Google was just starting to hire in 2003 because that business was starting to scale up, and like they had both the funding and the need to bring in a whole bunch of people. And so like I actually I worked a bunch in both search and ads, but like my first real project that I did at Google was an ads one.
And then you go on to lead the ad quality engineering team.
Yeah, I led a big chunk of the so like ads quality was the team at Google that built all of the stuff that effectively like ranks and filters ads. So it's like the CTR prediction stuff, and which you actually have to have for a like a second price auction to work. When you selected a set of candidate ads, like you actually have to like predict what the likelihood that someone is going to click on them in order to and you multiply that by the bid price to basically along with the other participants in the auction to figure out what the ad ranking is. So like you've got this big system for doing CTR prediction, which is like an economic necessity, and then like a whole bunch of other things like when should an ad not show up in the auction because like its quality is too low, or when are people trying to play like low quality arbitrage games in the system. So it's like a whole bunch of stuff that this team did, and like I ran a big chunk of it. I didn't run the team of economists and statisticians that were also
Mm-hmm.
technically part of the team. I worked for a guy named Mike Fromkin, who like actually ran the whole ads quality team. And Mike is awesome. Like he's like one of the best bosses I've ever had. Just an incredible guy.
Um, AdMob. So
Yes.
I think you're at Google the first time for a little, maybe under 4 years even. Um,
Three years and
3 years.
9 months, I believe.
Okay, okay. What interested you in AdMob and why head over there?
Um, I've I tended at the time, and I still do. Like I spent a lot of time thinking about what it is that I want to accomplish, and over a very long periods of time, and then I try to make a plan that helps me get there. And so I had spent basically from age 17 through age like 30, 31, and like my entire goal in life was to be a professor. And when that changed, I needed to get a new plan. And so I was at Google for about a year, and I figured out that maybe the thing that I can be good at that lines up with my interests is not just being an engineer, but helping other engineers figure out how to do their best work and how they can make an impact in the world and how they can achieve their own goals and career ambitions. So like, it started because I was at Google, and we yeah, we just had all of these brilliant people there, and we were hiring folks so fast that we didn't always have this prescriptive thing to tell them to go do, and like we gave people a bunch of freedom about what they chose to work on. And so I thought, okay, like it might be worthwhile for me to help people point themselves at things that are going to like be at the intersection of like what's going to produce value for Google and like what's going to align with their interests and expertise. Like that's sort of the the sweet spot, so to speak. And like I've been lucky that the thing that motivated me to go into industry in the first place was like I wanted to do something where I could scratch a whole bunch of technical itches, but like in a way where like it was going to have measurable impact. And so like I decided at that point that I was going to become a manager, and as soon as I decided that I was going to lead teams of engineers, like what I wanted to do was like, look, my new goal is to be the head of engineering at like a big internet company. And I knew that there was no way that I was ever going to be the head of engineering at Google. And so to me, like I was at Google, and like I tried to expose myself to like everything humanly possible to like help me have skills to and pattern matching and coping mechanisms for being um, the head of an engineering group, like the person with whom the buck stops, and who like has the the whole accountability for for an engineering team. And like I got comfortable at some point, and I was like, okay, well now like I want a head of engineering job. And I was like, okay, I think I can probably go get one at a startup. And I looked around, this is in 2007, at like all of the interesting things that were going on, and I was like, oh, this is like this is an interesting thing. Like I'm sort of jumping into the frying pan. Like there's a whole bunch of stuff about being a head of engineering at a startup and about startups themselves that I know that I don't understand, but like at least I understand advertising. At least I understand how to lead an engineering team this size, because like I'd led bigger teams at Google, and like when I got there it was like about 10 people in the engineering team. Like I knew from just a leadership perspective I could handle that. And like I could basically, that would give me enough of a buffer where I could sort of learn quickly all of the things that I didn't know how to do. And I knew also, just because like I've been sort of seeing some of the momentum in the mobile ecosystem, I knew that this was going to be an important thing. And like the problem that we were trying to solve at AdMob like really really spoke to me. It wasn't that like, okay, like let's go put some little irritating rectangular boxes on a small screen. It was if you'll sort of remember back, like I joined I joined AdMob before the iPhone had really launched. Like it had been announced, but
Right.
like not launched. And like our entire business at that point were text ads in WML applications, and like almost all of the running up to this. The way that a mobile application got distribution is like they had to cut a deal with a carrier to appear on their deck. So like this is sort of like the home screen for the phone.
There's
And
no app stores. Those things don't exist yet.
no,
Yeah.
none of that. And it was sort of like this major impediment to innovation happening, because there were all of these chicken and egg problems. Like, carrier is not going to talk to you unless you've got like some credible business story. And like a whole lot of the great ideas that have happened in mobile over, the intervening years, start off and like you can't really prove that they're going to be the success than they are. So it was just like this, like innovation really couldn't happen as fast as it needed to. And so AdMob was all about like, how can we give application developers a distribution mechanism where they can find an audience for their apps and services that they're building, and once they have that audience, like what's a mechanism we can give them to monetize it? And so it was basically about us trying to figure out how to deliver those two essential ecosystem components so that innovation could happen. And like the thing that felt really great about AdMob is that, we had this point, a few years after I started where, like it was just the crazy fastest growing thing I've been part of. Like the business was doubling at this ridiculous doubling interval. And like a whole bunch of the mobile companies that were getting funded at that time, like their monetization part of their business plan and their pitch decks was like AdMob, and like that was great. Like we were sort of doing exactly what we wanted to do, and it's awesome. Like the team that we had there, it's what the people have gone on to do is sort of awesome. So my director of engineering there is now the CTO at Instacart. Cheryl Dalrymple, who was our CFO, was the CFO at Polyvore, and she's the CFO at Confluent right now, which is this ridiculously successful company that is sort of bringing the whole notion of streaming data systems and real-time analytics and processing to the whole world based on Kafka. Jason Spiro is like one of the big advertising executives at Google now. Omar, the founder, is like a great investor at Sequoia. I mean, it's just and like Kamakshi Srinivasan, like one of the incredible data scientists, like she had PhD from Stanford and double E information theory. Like she's founded this company called Drawbridge. Like it's just like that team punched way above its weight. As I'm like way prouder of all of them than and like what we were able to do for the ecosystem than like a great many things that I've ever done in my life.
An AdMob mafia, as it were, like the PayPal
really.
mafia.
Yeah.
I'm gonna jump ahead to LinkedIn.
Yep.
You're the first person I think I've talked to from LinkedIn. So a really basic question. You've worked at Google and Microsoft and AdMob, so startups, all sorts of things. Just how is LinkedIn unique, or like even from a cultural level? Describe to me LinkedIn.
Yeah, LinkedIn is. I mean, like, look, I'm highly biased because I joined LinkedIn when like in 2011 before the IPO, and like my job was to like build that engineering team into like a big thing. It basically was the job that I had been looking for a very long while, like head of engineering at like a important internet company. And so like I'm super biased about the culture because like sort of the culture that the leaders and great engineers there in like this sort of full cooperation with with Jeff and the rest of the company, like it's just sort of the place that we wanted to be. And so we one of the things that we focused on a lot is LinkedIn's business like never had the like gigantic margins that some of the other big companies had, but like we had many of the same like technology challenges. So like we were sort of scaling at this incredible rate and huge amounts of data, and so like you take those two things together, like we had this like crazy need for focus and prioritization. And so one of the like we just sort of designed designed a culture around us being able to get the best possible technical and product outcomes that we could get from what always seemed to us like a constrained number of resources. So like collaboration, for instance, is like super important in an environment like that. You just cannot afford to have people working at odds with one another, duplicating a bunch of effort, like trying to, sort of advance their agendas through these sort of parallel and competing paths. Like you just really have to get people to come together as a team, and to recognize that the most important thing is for the entire team, like not to think as like, sort of a random confederation of slightly warring tribes, but like, you're one team. You're one team at 250 people. You're one team at 1,000 people. You're one team at 3,000 people. And like, you've got to always keep in mind the top level objective that you're trying to accomplish, and like be willing to play your part in accomplishing that objective, even if it means locally sub-optimizing what you're doing for some period of time. And
Well,
I think,
I saw just specifically to this. I saw there's a Business Week article and a Business Insider article that essentially say, to the level of like, you institute a code freeze at some point, that they say in these articles, like, essentially saved LinkedIn, as they say. Maybe that's hyperbolic, but like, you had to come in and do things to such a level that like, look, we got to get our eggs in order if this company's going to move forward.
Yeah, look, we I don't know, who saved Link. Like, it's no one individual ever saves anything. Like, that's just madness to think about. But the thing that we did know, like, we were in a precarious situation when I joined the company in 2011. Like, we had, we had a bunch of different product and engineering silos that weren't working well together, and like we had a software development infrastructure that basically couldn't support our ambition. So we were, it was just all kinds of craziness. Like we, at some point we decided to go to a service-oriented architecture, which is like a great thing. Like, service-oriented architectures mean that you've got things sort of, factored into a set of units that have independent scaling characteristics. So like you should be able to operate them independently of one another, like scale them independently of one another, and like they're, like small enough where they, have some sort of uniformity about them that let you, reason about them, like as a isolated thing, not necessarily in the context of the whole. But like we'd sort of split this thing up into a thing where we had more services in production than we had actual engineers. Like the services outnumbered the engineers, and they weren't independent of each other. Like you couldn't deploy like one service independent of the rest. And so there was that. Like we were doing this like feature branch based development, and like we would release the site, like all of these services in like one big bang, like once every 2 weeks. Yeah, so when I started, like I think it was Wednesday, like every Wednesday night, like you would expect that, 100+ people were going to spend all night, like getting the code that, that they had slammed down onto this integration branch and spent the previous, like multiple weeks trying to qualify. You would then push this thing out into production, and like you'd have these handwritten deployment plans like on wiki pages where it's like you do these 110 steps to deploy everything, and they're invariably in each one of the deployment plans there'd be some point where it's like, all right, this is the point of no returns. Like we can't even like fail all of this back if it doesn't work. Like if we have a problem after this, like we're gonna have to fix forward. And it's just, I could go on for like a really long time sort of describing like all of this stuff. But like the net of it was that it was taking, when I got there, up to a month for someone to check a piece of code in to the time that it showed up on the site. And that period was increasing almost as a function of the number of engineers that we were hiring. And when I started there, like the IPO was imminent. And so like we were just in this quandary. It's like, look, we got to keep growing the business. Like we've got all of this ambition, like all the things that we want to build. It's getting harder and harder to build them, not easier and easier. And like everybody, all the engineers, like, are super frustrated with how painful all of this is. They know that it doesn't need to be this hard, but like they couldn't figure a way to like get out of the trap. And you know, we knew for sure that if we didn't have a credible plan for how we were going to fix it, that 6 months after the IPO, when the lockup period expired, every good person was going to leave in short order. And then, like, not only would we be busted, we would lack the capability to fix ourselves. And so, like, there was like a huge amount of urgency, you know. So, like, that code freeze, like, where I basically said no new product development for you know, for a couple of months at the end of 2011. Like, that sounded to like a lot of the, you know, the people at the company like a really huge and risky thing. But like, I was looking at the, you know, the real risk was, you know, getting ourselves permanently into a state where, you know, like we couldn't build software. And so, like, to me, like, it wasn't that hard a decision to make. And you know, like, we got things fixed. And you know, this is also sort of the hard thing of going through a big transition like that. Like, if you have tried to fix a thing multiple times and failed, then like one of the big impediments to actually making a credible and successful attempt at fixing it is giving your team the confidence that the next try isn't going to be the same failure that the last ones were. And so, like, we had to do a bunch of stuff to like help people feel like, yeah, we're really going to do this. Like, this is going to work this time. And that, you know, maybe out of all of it was the hardest thing, because like technically, like, what we needed to do was sort of obvious. It was like just getting everybody together and, you know, sort of pulling in the same direction. That was the, you know, sort of the challenging part in the end. And then, you know, like you sort of, you know, we did all of this in November and December. Like, we, you know, like, we literally at some point in, you know, the end of November, early December, like, we had burned down the bridges to the old way of doing things. Like, we couldn't build code anymore. And you know, that was a nerve-wracking moment. But like, we spun everything back up in January. It wasn't perfect in the beginning, but the foundation was in place where we knew that if we continued to invest, that like we actually could get it really good, like, really quickly. And you know, we were, you know, more or less a completely different company in terms of engineer happiness and software development capability and product velocity by the middle of 2012. And if we hadn't done that, like, we would have been in real trouble, I think.
Well, then that brings us to present day, because then the acquisition brings LinkedIn to Microsoft, brings you to Microsoft. And in my notes, I was going to ask you, you know, why take the CTO job at Microsoft when it's offered to you. But now, having spoken to you, I think it's pretty obvious. Like, this is the chance to create the culture, the engineering culture, the ability to empower engineers to do great work at like the biggest scale imaginable, right?
Yes. So I'm glad that seems, because that's exactly it. It it scratches this amazing itch that I have, just in sort of terms of curiosity. Like, I've never had a better, higher bandwidth learning opportunity than the one that I've got right now, just because we have so many brilliant people working on such a crazy breadth of things. There's so many impactful things happening across, like, forget about Microsoft, but across like the entire technology landscape right now. You know, like, we're having, you know, just sort of moment after moment where, you know, like, it's not only is technology like having this like incredibly large impact on everyone's lives, I think people are sort of feeling the impact more and more in places that they didn't anticipate feeling it. And I think you have to, yeah, there's just this big responsibility in making sure that you are lining up all of those opportunities for tech to do interesting and great things with a real need to make sure that those investments are serving people well. Like the thing that I really loved about what Satya has done at the company, and like he's done a bunch of really sort of amazing things, but like just simple things like reframing the mission of the company uh, as empowering every individual and every organization on the planet to achieve more. So like that sort of entirely lines up with my worldview. Like I think technology is a platform that should fuel other people's creativity, other people's ambition, other people's desire to make businesses, to like change the way that they're doing things, improve their lives. And like I really do believe in this thing that Bill Gates said like a whole bunch of years ago, which where he defined a platform as like a thing that produces far more economic value for the people building on top of the platform than it does for the people who built the platform. So I think there are things like AI, for instance, where like that's how AI has to go. Like AI has to be a platform for other people to build on top of that benefits them more than the companies who are building the AI infrastructure themselves. Like just has to.
Well, yeah,
Um,
yeah. Go ahead.
but yeah, so
No,
I
what
think
I was gonna say, like, to wrap it up, there's so many things that Microsoft is doing that we could talk about, but let's do focus on AI, like as a lens to talk about what Microsoft is doing right now. Like I heard you say that there's almost this palpable excitement about the progress that's currently being made in the AI space right now. Like all of these years, we've been told it's right around the corner, it's right around the corner, and it almost feels like the corner is now and it's being turned.
yes, I think that's becoming increasingly obvious. I mean, for some of it, like the stuff that I was doing like years and years ago, like my very first project uh, at Google was a machine learning thing. It wasn't an incredibly sophisticated machine learning thing by today's standards, but it was an ML thing. And I've been doing this long enough now to just see from a developer's perspective how much easier it is today to build machine learning things than it was how long ago was that, like 16 years ago now, 15 16 years ago. I mean, just it's stunning, like some of the things that were just like incredibly expensive, time consuming, heavy lifts like way back then. Like you can imagine like a high school kid doing in a weekend at home. I mean, it's just sort of crazy the amount of power that the AI platform is already putting into the hands of folks. And like there's, I think, sort of it. I mean, like I shouldn't even be using the word AI because like it's almost a junk word, right? It's not like AI is one thing. It is like a sort of an umbrella term for a very very large number of sort of super specific things. But if you're thinking about machine learning, for instance, as this area of activity inside of the AI umbrella. There's sort of two interesting buckets of things going on right now. So like I think the tools have gotten good enough where you've got a larger and growing population of practitioners have access to these tools and are sort of out there sort of filling in this long tail of the AI possibility curve. So it's like these little applications that solve like really meaningful problems in like this incredible diversity of contexts. And the interesting thing there is like how do you make that population expand, where it was maybe hundreds or thousands of practitioners doing real like commercially impactful work 15 years ago, and now maybe it's like large tens of thousands of people, but like still like probably way more elite than it needs to be. Like how can you get that to be hundreds of thousands or millions of developers who like have these machine learning techniques as part of their repertoire? And then like the exciting thing, like on that push is how do you use the tools of machine learning themselves to allow people who actually don't have any programming experience at all to build things. So we bought this little company called Loeb a while back, last year, and like the thing that Loeb did and is working on right now, they're sort of pushing towards like having a open beta that everybody can sign up for, is like it's a simple enough machine learning development interface that you can use it to build machine learning applications with no programming expertise. And like let me give you an example, which I give to everyone. So one of the founders of Loeb, Mike Mattis, is a designer, like very, very good designer. He worked at Apple, worked at Facebook, was like one of the first, like I think maybe the first designer at Nest. Just brilliant designer. But like he's not a programmer by training. He lives in this off the grid house in Marin, and he's got a big water tank that buffers water for him. Like he's solar powered, so like I think they use solar generated electricity to run a well pump. But like you got to move the water into the tank so that at night you can use water, because you don't have electricity to run the pump. And so he wanted to build a web app that would tell him how much water is in this tank at any point in time. Now, like I'm an engineer, and the way that I would go solve this problem is I'd put a bunch of sensors in the tank. Like I'd, figure out like what the mathematical relationship is between the sensor output and the water level. I write a whole bunch of code. Like I'd put a Raspberry Pi out there. I'd, I like connect it up to some like complicated like internet crap. I'd write the web app. Like I just do like all of this stuff. And like, it's a perfectly reasonable, software or electrical engineering sort of way to solve the problem. But like the way that Mike solved the problem with Loeb is like I think way more approachable and intuitive. So he took a float and tied it to a rope, threw the rope over the end of the side of the tank, and tied a weight to the other end of the rope. And so now he's got this thing where, it's like a little more sophisticated than that. Like there's probably a pulley in there, but like that's sort of the basic setup. And so like now you've got this thing where the weight, as it moves up the side of the tank, it means that the float is lower and the water level is lower. And when when the weight moves down on the side of the tank, it means that the float is rising and there's more water. And so he pointed a webcam at it, and got a stream of images coming out of it, and then fed the webcam stuff into Loeb, and then like went in and made some manual measurements that corresponded to a handful of those images, and then pressed a button, and Loeb spits a model out that gives you a water level from the stream of images coming from the webcam. And so like that is way more intuitively approachable than like all of the crap that I had to stuff in my head over the course of like many years in order to solve the problem like the engineering-y sort of way. And so and Loeb is one among many sorts of tools where you're using the whole paradigm of machine learning and machine learning itself to sort of optimize some of the things in the back end to be able to empower people to, I don't even want to call it program, but like to develop software who like just haven't had any access to that superpower before. So like that's one thing I think that's interesting about AI. And then the other thing that's really interesting is almost like the other end of the spectrum, is that like there are just some remarkable breakthroughs that are happening right now on reinforcement learning and unsupervised learning, where we're able to basically remove some of the constraints that slow down the rate of progress for training big AI models. So like the constraint right now for like all practical purposes is like how are you going to get enough labeled training data for supervised or semi-supervised machine learning systems, and like how are you going to get enough compute to like train over large volumes of training data with like models that have very large numbers of parameters. And so what folks are doing in some of these in some reinforcement learning and unsupervised learning research and actual applications are removing that data constraint, that label data constraint. And so you think about some of these stunning results that folks have had in strategic gameplay, like AlphaGo beating the world's greatest Go player, or the OpenAI's DotaBot beating folks at Dota. And like even recently, there have been like a bunch of breakthroughs in natural language understanding that are based on unsupervised learning. Like both of these buckets of things are leveraging the fact that you can build bigger and bigger and increasingly interesting models by just being able to apply more compute to the problem. OpenAI's got this brilliant thing that they like this brilliant and insightful is probably the better adjective, blog post that they published last year, where they sort of show this progression of the number of petaflop days that have gone into training all of these remarkable AI models, going all the way back to 2012. And, like they sort of plot this out, and, like we basically, each step in the progression of, these awe-inspiring results are coming along with like an order of magnitude increase in compute power. And so it's exciting because I think this increase in computing power is like going to continue to come for a while. And I think both of those things are like maybe the two most interesting things happening in AI right now, from just in terms of like what I think is going to produce interesting and useful things for humans over the next, like, let's call it 5 to 10 years.
Well, a final question, because I think this is what I derailed you on that you were about to tell us about. So final question, how should we think about Microsoft's efforts and ambitions in all of this stuff, AI as the catch-all phrase in general? How should we think of what you guys are doing is different than what, say, other companies are doing in this space?
Well, I think, the thing that we're doing is, like we started as a platform company, like building software that, enable more computing in the world. But more computing was not really the interesting thing. Like what people did with the more computing was the interesting thing. And so like we really do, like through this mission and through like all of the businesses that we're running right now, like we see ourselves as a platform. Like we build things that help people to achieve the things that they're trying to accomplish in their lives, and like our business model aligns directly to that. Like if you have an AI workload that that you want to run, some interesting AI application that you want to build, like we have a cloud, like we've got a bunch of AI tools that we build, like we're giving you the capability to go build some of those things. And and it's like whether it's Azure ML, or it's Azure IoT, or whether it's Power BI for doing your analytics and visualizing your data, or it's Microsoft Excel that you're using to build your models to understand how your business works or to run your business, or even if it's productivity and collaboration. Like we build tools that help you get your stuff done. And like I think like focusing on like just sort of empowering folks is really really sort of the exciting thing for me, because like I think that's, ultimately that's what technology has to do. Like if you think about all of the the all of the I don't want to sound overly grandiose, but like
Don't worry about it.
the sort of technology and the progression of human society sort of go hand in hand. Like we don't have the world that we have today, and like we can't support our like way of life without like this progression of technologies that we've had, starting with fire and agriculture and the printing press and industrial manufacturing and electricity and refrigeration. And it's like sometimes I think we just sort of take a bunch of these technological things for granted, because like we become so dependent on them and like they're so integral to our lives that they fade into the background. And like we just sort of assume that they've always been there and they're always going to be there. And I think they're like if we sort of imagine our future, it's almost a certain thing that technological advancements that neither you nor I have fully conceived of or could even possibly imagine are going to be the things that are sort of receding into the the background and are sort of the default assumptions for like our kids and grandkids and subsequent generations. And so like being a facilitator for some of that, I think is like it's a huge responsibility. Like I think technologists in general like ought to be thinking about like how to, and it's not us, like we're not building the future, like we're building pieces that other people should be using to build the future. So that's sort of how I think about the world and like what we're doing at Microsoft.
Hey, since this is a podcast, should we mention your podcast real quick?
Sure. So I've been for several months now recording a podcast called Behind the Tech, and it's actually sort of a similar idea to what we've been talking about all along. Like I get the opportunity to work with and talk with and collaborate with all of these interesting folks who are behind the scenes, behind this technology that we're all increasingly using and dependent on and curious about and skeptical of. These are the folks who are building these things, and I just find it inordinately interesting to hear their stories, and to this is a podcast that like talks with some of these people, what's always surprising to me is, and this is like one of the primary reasons that I started doing this podcast, is there's this certain archetype that I think we all have in our head of like what a technologist is, or like what a Silicon Valley entrepreneur or a technology industry entrepreneur is, and like it's remarkably homogenous, like that archetype. And like when you actually go talk to the people, it's like they've got so many backgrounds, and like they've come from so many different places and different life histories, and they've had so many different journeys into their careers, and like none of it's linear or predictable, in a certain way. And like that to me is sort of like the fascinating thing. It's like anybody can be a technologist. Like anybody, I think, can do great things, like using tech to like make interesting stuff. And like the podcast is about talking to those people about that.
Well, Kevin, thank you for coming on this podcast and sharing your journey as a technologist with us.
Well, thank you so much for having me. This was a fun conversation. I really appreciate it.
If you like what you've heard on this episode, please support us by subscribing to the podcast so you can get great news stories and conversations every 2 weeks. And please buy the book that was based on this podcast, How the Internet Happened, From Netscape to the iPhone, by me, Brian McCullough. Order it now wherever books are sold. How the Internet Happened. And if you weren't aware, I host a daily tech news podcast every weekday that comes out at 5 p.m. In that show, I tell you what happened that day in the world of tech. It's only 15 to 20 minutes long, and it's great if you love tech news. Search your podcast app for Ride Home to find the show. It's called the Tech Meme Ride Home. Thanks.